So you already know what a factor is from our last video. Remember that when we think about factors, we are thinking about factories and how it takes smaller parts and puts them together to make a bigger product. Today we are talking about the difference between prime numbers and composite numbers. Prime numbers are only made up of the numbers 1 and itself as its factors. And composite numbers have more than 2 factors. So let's take a look at the first 100 whole numbers as an example. I'm going to cross out 0 and 1 because they are special numbers. Then I'm going to circle 2. 2 is a prime number because we can only multiply 1 and itself. 1 times 2 to get to 2. So it is a prime number. There are no other factors that make up 2. It's too small for it, actually. So I'm circling it as my prime number. Then I'm going to go down the line and I'm actually going to cross out all the multiples of 2. Remember, multiples are the numbers that we get when we keep multiplying. So 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and so on. All these even numbers are multiples of 4. And we're crossing them out because they are composite numbers. Remember, composite numbers have more than 2 factors, meaning it's not just 1 and itself that makes up that number. For example, one of the numbers that we chose, 6, right? So 2 was prime. 6, it's not prime because we can have 1 times 6. We can have 2 times 3, right? It has way more factors than just 1 and itself. So all of these multiples of 2 are going to have way more factors than just 1 in itself. First of all, because they're getting bigger and bigger, so they're going to have more and more factors that make it up. So all these are composite numbers. Remember, we just want to circle our prime numbers because prime numbers have factors of just 1 and itself. Okay, so far we just have 2. 3 I can also circle because 1 times 3 is 3, and there's no other factor that makes up 3. And I'm going to cross out all the multiples of 3. 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times, what am I at? 3 times 6 is 18, 3 times 7 is 21, and so on, okay? So I'm actually crossing out less and less because some of them were already crossed out with the multiples of 2. Hopefully I don't miss any. I kind of lost track here. Let's see, where was I at? 33. Okay, so let me just keep adding 3. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This will be easier. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, so far just 2 and 3. Then we're going to circle 5. 5 is a prime number as well because it's just 1 times 5, nothing in between there. You're getting the point. And then we're going to cross out all the multiples of 5, which are the numbers that end with 5 and end with 0. We already crossed out the ones with 0. Next we have 7. We're going to cross out all the multiples of 7. So 1, 2, 3, 4, 5, 6, 7 already crossed out. 1, 2, 3, 4, 5, 6, 7, already crossed out. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Cross. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I wouldn't have gotten that one. 1, 2, 3, 4, 5, 6, 7. Okay, so far we have 7 as well. Can't get any smaller than that with the factors. Let's see, then we have 11. All the multiples of 11. I feel like we already crossed out the ones with 11. So basically it's any numbers that are double, like 22, 33, 44, 55, and so on. I think we already got those. Then we have 13. I think the ones left over might just be our prime numbers, okay? So if you notice, they tend to be the numbers that end with an odd number, first of all, right? So 1, 3, 5, 7, 9, those tend to be our prime numbers. And again, prime numbers are those that can only be factored by 1 and itself. Okay, so those are prime numbers. Only has the factors of 1 and itself. All right, now let's talk about prime factorization, now that you know what a prime number is. Prime factorization is just taking a big number like 340 and breaking it down into its smallest possible factors. So we're going to factor until we can't factor no more. Okay? So it's kind of like your number bonds. Let's start off with the number 340, and then we're going to draw what's called a factor tree. We're going to break it down into smaller parts. Now remember, just like with your number bonds, you can choose whatever numbers you want, and there are no right or wrong answers, because at the end you're still going to get to the same answer. So if you decided, wow, 340 is a really big number, but I do know it ends with an even number and I want to start with 2, then you can break it down into 2 and 170, which is half of 340. Or you can look at 340 and say, hey, I know it's a multiple of 10, so 10 has to go into 340. I'm going to break it down into 10 and 34. Either way, you're still going to get to the same answer. If I wanted to break it down into 10 and 34, I'm going to actually keep breaking it down. 10 can then be broken down into 2 and 5 because 2 times 5 gets to 10. 34 can be broken down into 2 and 17 because 2 times 17 gets me to 34. So just like our number bonds, we're going to come up with numbers that it can be broken down into. 10 times 34 is 340. 10 can be broken down into 2 and 5. 34 can be broken down into 2 and 17. And again, we're going to keep going until we can't go anymore. Can 2 be broken down any further? Technically, yes, into 2 and 1. But remember, that just means that it's a prime number. So actually, we don't want that. 2, we're going to circle, it's done. 5 can be broken down into 5 and 1. That's it, because it's a prime number. So we're going to keep going until we end up with prime numbers. 2 is also a prime number, so we're done. 17, as we saw from our chart before, is a prime number because it can't be broken down into anything other than 17 and itself. So that's how we know that we're done. Okay? But let's say you didn't break it down to 10 and 34, you broke it down into 2 and 170. Then you would see 2, that part of the factor tree is done because I can't break it down anymore. Then I'm going to move on to 170. Clearly 170 can be broken down into smaller factors. Let's say 10 and 17 because it ends with 0. Okay? I'm actually then going to circle 17 because I can't break down 17 anymore. So notice how this 17 and this 17 are the same. This 2 and this 2 are the same, okay? And then we're left with 10. 10 I can break down further. 10 I can break down into 2 and 5, okay? 10 becomes 2 times 5. So at the end, no matter which factors I started off with, whether it was 10 and 34 or 2 and 170, I still end up with 2 times 2 times 5 times 17. 2 times 2 times 5 times 17. 2 times 2 times 5 times 17. Okay? So there are, I guess, quicker ways of prime factorizing, but they're all going to get you to the same answer. Okay? And these are composite numbers. These bigger numbers are composite numbers that can be broken down into prime numbers. There is a second method, but you would have to be really good with your prime numbers. And this method kind of looks like an upside down division bar. So what you're going to do is you're going to take the smallest prime factor and divide it. So 2 divided into 340, you would get 170. You would take that again and divide by the smallest prime factor to then get 85. 85 would then divide by 5 to get to 17, and then you would notice that you can't divide anymore. Again, it's a little more difficult. You would really have to know what your prime numbers are. It seems like it would take a lot of time actually, because you're just doing division over and over and over again, but it does get you to the same answer. So if you prefer that, you can definitely try that method as well. But just remember, prime factorization is you're breaking down the factors until you only have prime numbers left over. So you only want prime numbers at the end. Prime numbers only in your answer.